Welcome back everyone to our lesson 3 and lesson 4 exit ticket explanation video. So let's get started. In last Friday, I actually have this exit ticket, like very similar one to talk about this already, is we actually have a model which is talking about initially starting as something, and then after how many hours we have that many bacteria. So we know that so far when we read this question, we have never mentioned compound, we have never mentioned continuously. That means as our normal concept, we do not talk about the P naught, which is the one that looked like P0, and also the one that with the letter E. So we are actually using the model for A and B and T, and the middle is actually just the simple times. And here, the word initial, that means is indicating the letter A is going to be replaced by the number 2000. And right here, that means so far we have two unknowns. We don't know B, we don't know T. But normally in our function in our f of t, sorry, actually f of t inside ab, abt or f of x, abx, whatever the number that you're replacing, that means the only unknown can be only here for the x or the t when we call for exponent. Now, let me use the t. It's going to be easier for you to understand because we talk about time. The letter t is actually representing the time. So we know about 3 hours. We know about 3,500 as the ending. So actually when I actually trace it back, I can actually use all of these information to find b. That means to find our rate. So let me replace it right here. So I got 3,500. Let me erase this, become 3,500. And then replace that initial with the 2,000. So the A is gone, we have 2,000. Okay, and T is 3 hours, so let me actually erase the T and make a 3. Okay, now I have this, this, and this. That means the only unknown term right now is our rate, which is my T. And another word is our letter B right there. Okay, now, by doing a counter action, the counter, or actually an inverse calculation, we actually can find that R cubed is equal to 3,500 divided by 2,000, which means it's actually 1.75. And then how do you do a counteraction of cube? Now, normally we know that when I have a square, I'm going to do a square root. That means just a square root, just like that, because the 2 is actually hidden every single time. When I have a quadruple, 4 power, and then we're going to have a 4 power root. That means in the middle, I have a third power. That means I'm going to have a third power root, also called cube root. So that means I'm going to do a cube root on both sides. That is how you get your R. And in other words, when you punch in a calculator, actually, this is just about 1.20507, around that. Okay, now you have your R, finally. So actually, I can actually erase all of this place so that I can free up the space a little bit, but you should do it on the piece of paper on the side. So when I have this chunk, I'm actually having my R. I already have 4 hours. I already have my A, which is 2,000. So let's take a look at this. I have my initial, which is 2,000. I have my B, which is our rate, which is 1.20507. But to be more accurate, I would be the person who would prefer to use a cube root of 1.75 because you can keep punching this in your calculator and you don't have to round anything and you can keep your number more accurate. So for me, I would actually use the cube root of 1.75. And then it says 4 hours, so that means I just need to put parentheses right here and 4 hours. Because why do I actually just put a 4 rather than I need to translate into other numbers is because my unit for t is actually 3 hours. My unit for t is actually just hours. That's for unit for t. Okay, after you punch this whole thing in calculator, nothing crazy, all you gotta find is just like around 4217.73. Oops, 733. Now we know that this is bacteria, just like counting human being, just like counting things, living things. We talk about that on living things. We never get any of the living things as a decimal, right? So we have to get all the living things as a parentheses and rounding it, right? So let me move this on the side. Okay, So after the rounding, that means I have to round down because living things, I cannot, like half of a person, I cannot count as a whole person. 0.7 of a bacteria cannot be a whole bacteria. So I have to round it down. So 4217. If you round this number in before rather than using a cube root of 1.75, you're going to get any range between 4210 to 4225, any number between that. But if you're trying to be more accurate, keeping it as a cube root, that means do not simplify any of the decimals like right in the middle of the calculation. But after that, you can actually simplify it at the very end. So this is why a very good suggestion for you guys is to do not round anything in the middle. Okay, after that, second equation, now I have it. Second equation is asking about 80 minutes. Okay, I still started with 2000, same thing. And I'm a person that do not like to round stuff in the middle of an equation, so I'm going to still have 1.75 cube root. And then 80 minutes. Here comes the problems. Like my unit of time is in hours, and now I have a time in minute. Okay, so very simple. All you gotta think about is just like, oh, I got 60 minutes in an hour. So let me use 80 divided by 60 as my power for that root because I don't have an hour. I have to translate that 80 minute into an hour. After you punch this in the calculator, you actually got 2564.7578. Now, I know that again, this is a bacteria and decimal. I don't round whole numbers. I don't round all the living things into a whole number up, but rather I have to round it down because a 0.7578 bacteria as in one yet. So I have to round it down. So I got 2564. Now again, why did I actually not round it up? It's because, well, normal things I have to round it down. And if you're a person who is actually rounded the number of a cube root of 1.75 already, then you actually have a number within like the range of a 2560 to 2570. Okay, so those numbers are acceptable if you actually have their number rounded, which is our rate rounded, rather than keeping it as a cube root of 1.75. If you round this number, that's perfectly fine, okay? Okay, let's move on to the next question. It says, now find the time required for an investment to double the value if invested in an account paying 2% compound quarterly. Now in here, I finally encountered the word compound. So that means I am actually using the equation, which is including for this P naught, which is the P0. We call it P naught in physics. The zero actually I think I remember using in physics, but we usually just call it P0, or P naught would be more like a physics person call it. So P naught, this is what we start with, P0, and I want to double it. That means on the left side of my equation, I actually have the double P0, 2 times the P0. Okay, and then let me finish the other side. It says compound quarterly. How many quarter in a year? Okay, there are 4 of them. So let me label it as 1 plus the R. R is going to be the 2%, which is using 2% to convert it back into decimal. I actually have 0.02. After that, compound quarterly, right? So I have to divide by 4 because I got paid 4 times a year. And then on the upper exponent right here, up the right corner for the exponent, I actually have to have 4t because how many years I get paid each year, I actually got paid 4 times. Based on this, let's compare these left side and right side and see what's the first thing that you can get rid of. You can actually get rid of the P naught, right? So these 2 can be gone. Okay, after your simplification, you actually have a 2 on the left side. On the right side, you actually got 1.005 because you got a 2% divided by 4. You still have 4t though, nothing crazy. Based on this, I have a answer constant, and then this is your base, and this is your power. Remember how to translate this whole exponential form into a logarithmic form, right? So I have a log base. What's my base? 1.005. And then to the bigger number, which is your answer constant, which is going to be a gigantic 2. And then your power, which is your 4t. When you punch in the calculator, this left side you're getting is actually just 138.9757 with a bunch of decimal. This is your 4t. by dividing by 4 on both sides, your t is actually just equal to 34.7439. And we know that that's actually just the unit in years. So it's around 34.74 years. Or you can call it 34 years and 3/4 because, or three seasons, if you would like to call it that way. So because it's in year, we can actually round up or round down because it says approximately what time. So you can actually say 34.5 years, 34 years and 3/4, 34 years and 3 seasons. Okay? So what if I'm saying that, let me erase this whole thing actually. What if I'm saying that, how long would it take my money to actually triple for the whole time? Well, I just need to think about the number S. Let me erase this too. Well, I'm actually going to start with this beginning, this P naught, the same invested money. And then if I'm saying triple, then all I got to change is just the letter 3, the number 3. Okay. And the same thing. It doesn't matter how much I put it invest in the beginning. All I got to do is just cancel that number. I actually don't really care about how much money I put in. I care about how long would it take me for tripling, right? So we're going to take the whole same procedure. 3 equal to 1.005 to the 4t. And then this is all you got to do. And then you got to translate it into a logarithmic function so that you can actually find the answer. At the end, you know that you find the answer for 4t. You got to do a divide by 4 action on both sides. So then to find out how long would it take for you to triple. So the procedure is going to be the same. And just a hint, this is definitely going to be an exam, but not triple, but just double. Okay, so we have to get practice on how to actually find a relationship to the beginning initial and the ending number. If I'm telling you that it's going to be double, all you got to think about is like double my initial money, just 2 P naughts or 2 P zeros. It's very simple. Just all you got to do is just set the ending to 2 times the beginning. Okay, let's take a look at lesson 4. And lesson 4 right here is all about the logarithmic relationship. Now in here it says evaluate. And then keep 3 digits after decimal. It's all I care about is just rounding. So in here, when you punch in a calculator, punch in log 64. And we know that log 64 is actually having a hidden number as a 10, right? So which is going to be log base 1064. But your calculator already provide a very simple log. So all you got to do is punch in log 64. You got a 1.806 179974. Now, I actually need to round it to 3 digits. That means I need to care about the 4th one. Thus, the 4th one is heavy enough to change my fate on the 3rd one. Well, a 1 wasn't actually changing anything, so I know that when I round to is 1.806. Again, rounding is very, very important. Now, let's take a look at the next one. When you have this, when you punch in a calculator, you got a negative 1.39794. Again, I have to find the 4th one to see if I'm actually heavy enough to change my fate on the 3rd one. Well, it is because anything that greater or equal to 5 is going to impact the previous number. Anything less than or equal to 4 is not going to change other people's fate. So in here, I'm going to round it to negative 1.398. This is how it's going to change it. So if you haven't get any of the rounding correctly, please make sure that all the rounding are correct. Now in here, next one is only asking you to rewrite each equation to the log form. Now, all we got to do is just label, this is the base, this is the power, this is your answer constant. Base, power, answer constant. Answer constant, base, and this chunk is going to be your power. So let's change it. Log, base, answer constant, power. Now in here, I got a lot of friends telling me that this is going to be log 7 to the 49th power. I know that it looks so much like it, but the base have to be same side like this. Just like drawing, pretend there's a pre-exist dash line. So, and then the 49 is going to be, the 49 is labeled the same height as the L. So this is just like writing a small uppercase and a lowercase numbers and letters. Okay, we're gonna write the numbers into letters with uppercase and lowercase. Pretend the 49 is gonna fit the whole line with the L, and then the 7, which is our base, is gonna fit the line with the bottom one. Okay, so this is going to be one of our understanding of, oh, is it a superscript or is it actually a subscript of the 7? So the 49 is going to be a normal size, but the 7 is going to be a subscript. Okay, now the 2 is going to be the same size. So see, look at this one. Let me change the color actually. So the L and the 49 and 2 is actually going to be the same size, and the 7 and the L and G is going to be the same size right here. So this is just about how we actually keep it as a normal form. Okay, now I'm going to keep writing. The next one is going to be a log, base. Oh, and I'll put a 4. Answer constant, which is going to be a quarter. And then your exponent, which is your power, is going to be a -1. Now, I know that 1/4 and 4, you don't want to confuse these two numbers because when you have a fraction, it might be confusing. So you can put a parentheses. Or if you're a person who is actually very good at writing all of these numbers, you don't need the parentheses. Okay, very last one. Very same thing. Base. Oh, I see the E right there. And then you see the answer, which is going to be the letter Y. Okay, Y. And then I can actually erase this, but like this is a letter, this is another letter, so I don't want to confuse myself. This is why I put it parentheses. It's okay not to put it though, by the way. It's okay not to put it. And then the very last one is going to be exponent, which is going to be 3x. Now, one more thing that I want to mention is if you see the word log E actually stands for ln. So you can put ln y equal to 3x. Now, a lot of my friends like ask me that why do I put the L like this? Why rather than a regular L? It's because in college, all the professors gonna ask you, oh, pretend this is gonna be looking like this so that you distinguish this with every single unknown number. So if you put LOG, people might think, oh, is it a 10G? Is it a 1.0? Or maybe you can have a dot by accident right there. So it's gonna be 10G or 10G. What is this? So writing this in together, LOG together, they know that, oh, this is actually the English word logarithmic, just LOG for short. So again, writing that in script, let me write it better. So everybody will know that this is going to be a log. It's not like me forcing you to do it like this. You can do it like this perfectly, but we know that what we're talking about. But in the future, when you are in a higher form of math courses, all the professors going to know that, oh, writing in LOG in script is going to be the best way to distinguish from English to numbers. Okay, so this is lesson 3 and 4.